Hello everybody and welcome back to another video. In this video I will be covering the distance traveled by a particle in a given time span. Now in this question, a particle travels in three-dimensional space, so that means that we are working in coordinates x, y, z. So we are going to have a function with an input t that outputs x, y, z. So the position is modeled by x of t is equal to x, y, z, where this is x as a vector, which means that just the position. So ignore that these two are the same. They have no correlation besides that this is just the first part of this. So x of t is equal to x, y, z, which is equal to e to the t cosine t, comma e to the c sine of t, comma e to the t. So that means that, let's say each t, so from t equals 0 to t equal 1, let's say that's 1 second. So that means that in that 1 second, the particle moved from its initial position, which in this case would just be, so if it moved from, it'd have some weird decimals in it. However, this is just saying that you move this far in the x direction, your position is this way in the y direction, and your position is here in the z direction. So we are looking for the distance traveled from t is equal to 0 to t is equal to 4. So you might be thinking, oh, this is easy. You just do x of 4 minus x of 0 is equal to your distance. However, that would give you your displacement, which is a vector. Distance is a scalar quantity. And I will give you an example of what distance is over here, and then I will tell you how to find it. So let's say that this function, which is in 2 dimensions, travels the path as follows from t equals 0 to t equals 4. This is x, this is y. So this is what you just said to solve for, or what I guess hypothetically you just said to solve for. This is your displacement. However, we are looking for this right here, which is your distance. And we are looking for the length of that. So if you were to stretch this out, how long would this arc be? So we're looking for the arc length, which is your distance. So how do we find that? So let's look at our equations from physics. So we have v, which is our velocity, is equal to our displacement divided by time. And these are both vectors. So we also have the equation that our speed, which I'm modeling with s, even though that's not how you typically do it in physics, speed, which has no vector sign on top of it, is equal to your distance divided by time. This has no vector over it either. So since speed is the magnitude of your velocity, that means that we could say the following: the absolute value of the velocity vector is equal to our distance divided by time. So what this also is saying is that the absolute value of our velocity vector is equal to d of d over dt, where d is what our x would be usually. It's just kind of weird since we have two of them. So if we multiply both sides by dt, we get the magnitude of v dt, and let's integrate that from 0 to 4. T equals 0 to t equals 4 in this case, or I guess we could just say t naught to t1 is equal to our change, or I guess since it's a scalar, this is just equal to our distance traveled. So our formula for distance, or our arc length, is d is equal to the integral from t naught to t1 of the absolute value of our particle's velocity with respect to time. Now, if you remember, here, let's go back up here. If you remember, our velocity is the derivative of our position with respect to time. So this outputs, I will say, x prime, comma, y prime, comma, z prime. And the magnitude of this, it does not equal this, it's the magnitude of this, which is equal to, we actually have to do a Pythagorean theorem on this. So this becomes the square root of x prime squared plus y prime squared plus z prime squared. So this is our function for our velocity's magnitude. I need to save some space over here for the algebra later. So when we integrate this, this says that our distance, so d is equal to the integral from t naught to t1 of the square root of dx over dt squared plus dy over dt squared plus dz over dt squared dt. So this is our equation for our distance traveled, much harder than x of 0 or x of 4 minus x of 0, am I right? So now let's apply this formula to this problem right here. So to begin, we will find our velocity as a function of time, which is equal to, I'm going to have to write small here, so we need a product rule on this since we're taking the derivative, so this is d over dt. So when we use the product rule on here, we leave e to the t, and then we take the derivative of, or we could take the derivative of e to the t, which is just e to the t, then multiply that by cosine of t, then add that to, which will become negative over time, but we add it to the derivative of cosine of t, which is negative sine of t, so that's why the negative's there, times our function right here, which is just e to the t, so that's our x coordinate of velocity. Now we do the same thing over here, so we leave e to the t, then sine of t, then we add e to the t times the derivative of sine of t, which is just positive cosine of t, and then the derivative of e to the t is just e to the t, so this is our velocity as a function of time. Now we will be taking the absolute value of our velocity function, which is equal to the square root of this, which is e to the t cosine of t minus, I will actually factor out this e to the t, e to the 2t, since we had to square it, cosine of t minus sine of t squared, plus e to the 2t sine of t plus cosine of t squared plus e to the 2t. So now we can pull out, or we can just multiply this all out, so this becomes, this is going to be a long one right here, e to the 2t times cosine squared t, since we are foiling this out, since this is squared, minus 2 e to the 2t, since we are multiplying this in, 2e to the 2t cosine t sine t, then plus sine squared t, this is times e to the 2t, so this is plus, so these two are going to cancel since this is sine squared plus cosine squared, and just leave us with, so this becomes the square root of e to the 2t, since those two turn into 1, minus 2e to the 2t. Then for our second term, we have e to the 2t times sine squared t plus 2 cosine t sine of t plus cosine squared t. I know I'm eating into this paper over here, but please ignore me. And then there's also, from this function right here, plus an e to the 2t there, which I know I'm incredibly into this, but just try and remember it's there. So this becomes, these two added together to form 1. So it becomes plus e to the 2t. Oh, I forgot to multiply this by the other term. Okay, so my hands are incredibly covered in chalk. E to the 2t cosine t sine of t. Now we are going to add e to the 2t plus, now we have this term right here, which is just e to the 2t times cosine of t sine of t plus e to the 2t. Now if you notice, this is negative 2e to the 2t cosine t sine t, and this is positive e to the 2t cosine t sine t. So these just cancel out for 0. So this becomes e to the 2t plus e to the 2t plus e to the 2t under this, which is just equal to the square root of 3 times e to the t. So what this tells us is that this is our magnitude of our velocity, which is equal to our speed. So this is our speed function. So now we just need to integrate that. So this now becomes the integral from 0 to 4 of the square root of 3 times e to the t dt. So this is just a very simple integral. We can pull the square root of 3 out, so it becomes square root of 3 times the integral from 0 to 4 of e to the t dt, which is just equal to the square root of 3 times e to the 4 minus e to the 1, or e to the 0. And since e to the 0 is just 1, this becomes radical 3 e to the 4 minus radical 3, and that is our answer. So I will write that right here. The square root of 3 times e to the 4 minus the square root of 3 is equal to our d value. So that is a lot of algebra right there, but everything ends up canceling out luckily. So this is our equation for our speed. I just did that right here. Before I plugged in the integral, we got this. I integrated that, and that is our answer. So I hope you all enjoyed this video and like this problem as much as I do. This is one of my favorite problems of all time, as everything just starts to cancel out over time. So I hope you all enjoyed this video. Please like and subscribe, and thanks for watching.